Earth. It has it all. It's the darling of our solar system, a genuine unicorn of a rock floating through space. But the Earth and our universe in general isn't always a friendly place. Asteroid or comet impacts, megavolcano eruptions, even man-made threats like nuclear war are more than capable of extinguishing the flame of consciousness on our little blue ball. In fact, this has already very nearly happened on 5 separate occasions, known as the Big 5 mass extinction events. So a backup to consciousness would be nice. Ideally, another Earth. And that's where the hunt for exoplanets comes in. My name's Brad, you're watching Hello from Space, and today we're going to be taking another tour of space, but this time out past our solar system to some of the most promising exoplanets nearby, relatively speaking, that could support human life. Now, these are 7 of the most promising exoplanets we've discovered to date, what we know about them, what makes them special, and what life would be like on them. Now, there are some really interesting ones on this list: super Earths, water worlds, even an exoplanet in a trinary star system. So let's start off with the first of our possible Earth sequels. Imagine standing on the surface of an alien world just over 4 light years from Earth. The sky is dim, bathed in not the golden glow of our sun, but in the crimson light of a red dwarf star. Shadows stretch long across rocky terrain, and the sun, if you'd even call it that, glows like a dying ember. Now, this is Proxima Centauri b, the closest potentially habitable exoplanet to Earth, and possibly our most realistic first step out of our solar system. Discovered in 2016, Proxima b orbits Proxima Centauri, a small red dwarf star that's part of the Alpha Centauri triple system. Now, exoplanets are generally named after their star and given a letter designation based on the order in which they were discovered. I had actually always thought that the letter designations were given in order of the distance from the star, but I was wrong, that isn't the case. It was found using the radial velocity method, where astronomers detect subtle wobbles in a star's motion, sort of tiny gravitational nudges from an orbiting planet. Now, these wobbles create shifts in the star's light, giving away the presence of something massive but unseen. Now, in this case, the unseen object turned out to be a rocky world about 1.17 times the mass of Earth, locked in an 11.2-day orbit, incredibly close to its parent star, just 0.05 astronomical units away. Now, 1 astronomical unit is about 149.6 million kilometers, so 0.05 AU is roughly 7.5 million kilometers. Now, unless you're an astronomer, you probably have no reference on how close or far away that is. So for reference, the Earth is 1 astronomical unit away from our sun. It's actually where we get the unit, with 1 AU being defined as the average distance from the Earth to the sun. The Earth is 20 times farther from our sun than Proxima b is from its star. And yet, thanks to the star's cool temperature, that tight orbit places Proxima b right in the habitable zone, where temperatures could allow for liquid water on its surface. Now, that's only the beginning of the story. Proxima b may be close, but it's a bit of a difficult neighbour. Now, as a red dwarf star, it's long-lived but faint and highly unstable. It regularly unleashes powerful stellar flares, bombarding the space around it with X-rays and ultraviolet radiation. Now, in 2019, one such flare briefly increased the star's brightness by over 14,000%. That's one hell of a stellar mood swing. Now, for Proxima b orbiting so close, these flares could be absolutely catastrophic. Now, without a strong magnetic field to protect it, like Earth's, there's a high likelihood the planet's atmosphere could have been stripped away over time, essentially leaving a lifeless, airless rock orbiting around its intermittently very cranky star. Truth is, we don't know for sure. It's possible Proxima b does have a strong magnetic field, or that it started with an atmosphere dense enough to resist erosion, maybe even thick with CO2, or even with an ocean beneath a protective cloud layer. Now, in 2021, scientists tried to detect carbon monoxide with the ALMA telescope in Chile, a potential clue that the planet has an atmosphere, but the results were inconclusive. Now, in the near future, telescopes like the JWST, or the James Webb Space Telescope, might give us better answers. There's also the matter of Proxima b's likely tidal locking due to that very close proximity to its star, with one hemisphere in continuous daylight and the other in endless darkness. Basically, it quite possibly doesn't spin on its own axis in the same way the Earth does around the sun, Rather, it's locked in a sort of constant staring contest with its star. This in all likelihood could create extreme temperatures on its surface, unsuitable to life. One half of the planet being blisteringly hot and the other half being basically a frozen wasteland. Now, this being said, it's also possible that a functioning atmosphere might circulate heat around the planet, making the so-called Terminator Zone, a twilight band between night and day, a habitable ring of moderate conditions between the two. Now, if water exists, it might pool in this zone, sheltered from the worst flares, providing a potential refuge for life. By the way, that very, very cool term, Terminator Zone, which we're going to be using a few times in this video, was coined by Dr. Anna H. Lobo and team in their 2023 paper, Terminator Habitability, the case for limited water availability on M-dwarf planets, which is a super interesting read if you're so inclined. Still, the most exciting part of Proxima b is probably how reachable it is compared to our other options. Now, sitting at a measly 4.24 light years away, 4.24 makes it sound really close, like, oh, it's just 4.24 away, that's not far, is it? Well, for reference, 4.24 light years away is around 40.1 trillion kilometers, or for my American friends, just shy of 25 trillion miles. So I say it's close, but on a universal scale. Now, this relatively close distance makes it probably the most logical first target for interstellar exploration. And that's why physicists like Stephen Hawking backed Breakthrough Starshot, a pretty genius plan to launch tiny laser-driven probes that could sail to Proxima b at 20% the speed of light, arriving in around 20 years. Now, if successful, these incredibly compact spacecraft could send back humanity's first close-up images of a true extrasolar alien world. Now, because of a distance, we'd still have to wait another 4.24 years to receive the images, but this is still incredibly exciting that we could see real photos of an exoplanet within our lifetimes. Now, Proxima b may just turn out to be a dead, radiation-blasted rock, or it could be our best first shot at finding another Earth. Either way, it's probably the most compelling first destination beyond our solar system. A world close enough to touch, but mysterious enough to get our imaginations going. In 2015, NASA's Kepler Space Telescope spotted something pretty remarkable. Far beyond our solar system, over 1,200 light years away, a tiny, almost imperceptible dip in the light from a distant star revealed the presence of a new world, Kepler 442b. Now, while faint and distant, this planet immediately captured scientists' attention because it ticks many of the boxes that make it one of the most Earth-like exoplanets we've found to date. Now, Kepler 442b is about 1.3 times the diameter of Earth. Now, this size suggests that it likely has a rocky surface rather than being a gas-dominated mini-Neptune, and could support an atmosphere capable of sustaining liquid water. Now, its star, Kepler 442, is a K-type orange dwarf, a stellar class that's often described as sort of an ideal host for life-friendly planets. Now, these stars are cooler and smaller than our sun, but far more stable than volatile red dwarfs, which often unleash powerful stellar flares, as we discussed with Proxima Centauri. Now, moreover, K-dwarfs live much longer than our sun as well, tens of billions of years, compared to our sun's expected lifespan of just 10 billion years. Now, this extended lifespan gives any potential biosphere on Kepler 442b an incredibly long window to develop and evolve. Now, Kepler 442b orbits its star every 112 days, placing it comfortably in the conservative habitable zone, the region around a star where conditions are just right for liquid water to exist on the surface. Not too hot, not too cold. Now, this orbit means the planet likely experiences pretty temperate climate, although exact surface conditions depend heavily on its atmosphere, which we have yet to characterize. Now, what's particularly fascinating about Kepler 442b isn't just its size or orbit, but its location in a region of long-term orbital and stellar stability. Now, in cosmic terms, the system appears to be a pretty calm neighborhood. Now, unlike many exoplanets orbiting highly active stars or caught in chaotic gravitational interactions with neighboring worlds, Kepler 442b's environment is relatively placid. And this means if life ever did get a foothold there, it would have had potentially billions of years to flourish and evolve, potentially reaching levels of complexity similar to or beyond life on Earth. Yes, aliens. Hopefully the friendly kind, not the kinds with glowing green blood, or the more buggy kind with a taste for sugar water. Now, we currently have no way to physically visit Kepler 442b. At 1,200 light years away, it's unimaginably distant, far beyond even the fastest spacecraft concepts humanity has ever proposed, and well outside the realm of near-future exploration, probably even outside the realm of science fiction. But that's with our current technology and understanding of physics, which is always improving. Now, technological development tends to be sort of exponential. It's technically more of an S-curve, but without knowing where the ceiling really is, who knows what sort of unimaginable technology we'll have access to in the somewhat near future. I don't know, maybe within the next 1 to 500 years. Still, Kepler 442b remains one of the highest priority targets for ongoing and future telescope observations. Now, with telescopes like the JWST and the upcoming extremely large telescopes on the ground, astronomers hope to analyse its atmosphere through spectroscopy, searching for hints of water vapour, oxygen, or other potential biosignatures. Now, the TRAPPIST-1 system is one of the genuinely most extraordinary planetary systems we've ever discovered. Now, in 2017, scientists announced that this tiny red dwarf star, located just 39 light years away in the constellation of Aquarius, hosts 7 Earth-sized planets, all packed into a space smaller than Mercury's orbit. Now, it was an unprecedented and astonishing find. A compact, stable, and potentially habitable system right in our cosmic backyard, so to speak. Now, TRAPPIST-1 is an ultra-cool red dwarf, about the size of Jupiter, but with far less mass and brightness than our Sun. Now, because of its faintness, all 7 planets orbit extremely close, completing one orbit in just a few Earth days. But yet, remarkably, 3 of them, TRAPPIST-1e, F, and G, lie within the star's habitable zone, where temperatures could allow liquid water to exist on the surface. Now, of these, TRAPPIST-1e stands out. It's a near twin of Earth in terms of size and mass, suggesting a rocky surface and likely an iron-rich core. Its orbit, climate zone, and overall composition make it one of the most promising exoplanets for habitability that we've ever found. Importantly, its host star is relatively quiet, especially compared to other red dwarfs, which, as we've discussed, are notoriously pretty cranky. Now, TRAPPIST-1's calm demeanour gives its planets a better chance of holding onto their air and potentially any life that might exist there. But what really sets this system apart is the company TRAPPIST-1e keeps. Now, these planets are tightly spaced and gravitationally linked in a complex dance known as orbital resonance, which keeps the entire system stable over long timescales. From the surface of one world, others would appear as giant glowing disks in the sky, many times larger than our moon. Now, can you imagine how unbelievably amazing that view must be? Now, if we ever develop the ability to send probes or even humans beyond our solar system, TRAPPIST-1 would be more than just one single destination. It would be a planet-hopping expedition. One interstellar mission could potentially explore multiple Earth-sized worlds, each with slightly different conditions, atmospheres, and possibilities for life. Of course, getting there remains a monumental challenge. Now, at 39 light years away, it's a little further than a hop, skip, and a jump away. But that being said, every exoplanet is. For now. Now, in the meantime, we're already studying this system intensively. Now, the JWST, for example, is currently observing the TRAPPIST-1 planets using transmission spectroscopy to search for atmospheric gases like water vapor, carbon dioxide, methane, and oxygen, potential biosignatures that could hint at alien life. Now, TRAPPIST-1 isn't just another exoplanet system. It's a cosmic treasure trove, a rare, nearby collection of rocky worlds around a quiet star, offering us a unique laboratory to study the planet's evolution, habitability, and the possibility of life beyond Earth. Now, if we ever venture to another star system, this might be the one worth the journey, not just for a single landing, but for a grand tour of 7 possible alien Earths. Picture this, you're standing on the surface of a rocky planet beneath a dim red sun. But in the sky, you can see 3 suns, one brighter, closer crimson orb dominating the sky, and then 2 more distant companions glowing faintly like dim red lanterns in the cosmic dust. Now, this is the bizarre and beautiful reality of Gliese 667cc, a super-Earth orbiting a red dwarf that's part of a trinary star system, or triple star system, in the constellation Scorpius. Now, at just 23.6 light years away, Gliese 667cc is pretty close on that universal scale I've mentioned. Now, it was discovered in 2011 by the European Southern Observatory, again using the radial velocity method. The planet has an estimated mass about 4.5 times that of Earth, which suggests stronger surface gravity and likely a thick, stable atmosphere, two ingredients very important for habitability. Now, when it comes to gravity, you'd be forgiven for assuming that a planet with 4.5 times the mass of Earth would have a crushing gravitational force. But the good news is that's not necessarily the case. Now, while we have a reasonably good estimate of Gliese 667cc's mass, we don't know its exact radius, and that makes a big difference. Surface gravity depends on both mass and radius. In fact, gravity at a planet's surface increases with mass, but decreases with the square of the radius. To put that simply, yes, Gliese 667cc has more mass than Earth, so it exerts a stronger gravitational pull overall. But if that mass is spread out over a significantly larger area, or radius, the gravitational force at the surface becomes more diluted. Now, to try and make that make sense, imagine you're standing on a trampoline and someone really heavy steps onto it. Now, if they're standing upright in one small spot, they sink deep into the trampoline and you feel a strong pull downwards towards them because all that weight is concentrated in one place. Now picture that same person lying down flat, spreading their weight out across a much wider area. Now, they're still just as heavy, but the trampoline doesn't dip as sharply in any one spot, including where you're standing. The downwards pull you feel is much less intense. Now, that's simplistic, but similar to how surface gravity works on planets. Now, if the planet's mass is spread out over a bigger area, or a larger radius, the gravity you feel at the surface is weaker because you're farther from the center of all that mass. For example, if Gliese 667cc is about 4.5 times Earth's mass, but roughly 1.8 times Earth's radius, its surface gravity would only be about 1.4 times Earth's gravity, a far more manageable number for humans. Now, this might sound counterintuitive. How can a planet have 4.5 times the mass of Earth while only being 1.8 times the size? And that's because volume increases with the cube of the radius. Or in other words, small increases in radius lead to large increases in volume and mass, depending on composition. So while we can't pin down the exact gravity yet, it is possible that Gliese 667cc's gravity is within a reasonable range for human habitation. Hopefully that makes sense. I know not everyone is a math person. Now, Gliese 667cc orbits extremely close to its parent star, completing one orbit in just 28 Earth days. But because the star, Gliese 667c, is a faint red dwarf, this tight orbit actually places the planet squarely in the habitable zone, where temperatures could allow liquid water to persist. Now, despite the star's cooler output, the planet still receives about 90% as much stellar energy as Earth, mostly in the infrared spectrum, which could lead to different photosynthetic pathways for hypothetical life. Now, one of the most interesting aspects of this system is its compact architecture. Gliese 667c is just one star in a gravitationally bound trio. Now, its two larger companions, the Gliese 667a and Gliese 667b, orbit much farther out, but they may still be visible from the planet's surface, offering a permanent view of multiple suns. If we don't name this planet Tatooine, what are we even doing? I know it's not technically right because Tatooine had two suns, but still, that is a clear slam dunk. Now, within Gliese 667c's immediate orbit, astronomers have detected at least one other planet, possibly more, in or near the habitable zone. Now, this opens up a tantalizing possibility of an entire system of habitable or near habitable planets all around a single quiet red star. However, like many planets that closely orbit red dwarfs, Gliese 667cc likely experiences tidal locking, where one hemisphere always faces the star, as we discussed earlier. That obviously has the potential to create some pretty extreme conditions, scorching heat on the day side and deep freeze on the night side. Now, that being said, there's still the aforementioned Terminator zone, which could be just right. Now, there are many unknowns and concerns, particularly around the same angry red dwarf star issues, which are starting to become a bit of a broken record. But Gliese 667cc remains one of the most promising super-Earths discovered so far. Now, its mass, location, and stellar environment make it a top target for future atmospheric studies using tools like the JWST or its future successors. Now, some exoplanets make headlines and then sort of quietly fade into obscurity. TOI 700d didn't. Now, discovered in 2020 by NASA's TESS mission, this Earth-sized world has remained one of the most intriguing finds in recent years. And not just because it orbits in the habitable zone. At just over 100 light years away, TOI 700d is part of a rare and tantalizing system. Now, it's about 20% larger than Earth and almost certainly rocky. Now, you might be thinking, hang on, if it's 20% bigger than Earth, doesn't that make it a super-Earth? That's a great question, and 10 points to you if that's what you were thinking. Now, super-Earths are genuinely defined as Earth-like planets that are between 1.5 to 10 times larger than Earth. Now, TOI 700d falls below this designation, and therefore is classified as Earth-sized, even though it's 20% bigger. Now, perhaps its most notable feature, it belongs to a multi-planet family that includes at least 4 confirmed planets, 2 of which lie within the star's habitable zone. Now, that alone makes TOI 700 one of the most compelling nearby systems for further study. Now, the host star TOI 700, a cool red dwarf, is notably stable, which is becoming a bit of a recurring theme among the more hopeful candidates. So let's skip the flare lecture and just move on to some of the more interesting factors. Now, what sets TOI 700d apart isn't just where it is, but how much we've already been able to learn about it despite its distance. Now, because the planet transits its star from our point of view, meaning it crosses over its star from our vantage point, astronomers can study the way starlight dims and even use emerging techniques to probe the atmosphere, assuming it has one. Now, that's a big deal. For most small rocky exoplanets, we don't get that kind of observational opportunity. And with TOI 700e, discovered in 2023, and also in the habitable zone, we now have 2 Earth-sized worlds orbiting the same star, both potentially hosting atmospheres and possibly life. The orbital setup is worth noting. Now, TOI 700d completes an orbit every 37 Earth days, placing it slightly farther out than its sibling E. Now, this is one of those examples I gave earlier, where TOI 700e is actually closer to its star than TOI 700d, which seems wrong, but this is because they're named in the order in which they were discovered, not in order of their proximity to their star. Now, some models suggest it could have a thick enough atmosphere to circulate heat around the planet, avoiding that permanent freezing and boiling zones typically associated with tidal-locked planets. And then there's the broader implication. The TOI 700 system shows that compact, stable multi-planet systems with multiple habitable zone candidates aren't just theoretical, they exist and may be much more common than we thought. In a galaxy of billions of stars, TOI 700 stands out not just because it might host a habitable world, but because it might host 2. That alone earns it a top spot on the shortlist for the most promising exoplanetary systems we've discovered to date. Kepler-22b was one of the first exoplanets to truly stir the public's imagination. Now, discovered in 2011 by NASA's Kepler mission, it was the first confirmed planet in the habitable zone of a Sun-like star. And while it's far from the perfect Earth twin, it might be one of the better candidates for long-term human exploration, or scientific curiosity at the least. Now, located about 620 light years away, Kepler-22b orbits a G-type star that's just a bit cooler than our Sun. Now, the planet itself is about 2.4 times Earth's radius, which puts it in the category of mini Neptune waterworld. Not quite rocky, but not a gas giant either. That in-between zone is tricky to pin down. Now, some models suggest Kepler-22b could have a small rocky core surrounded by a deep global ocean, potentially hundreds of kilometers deep, with a thick atmosphere on top. Here's the catch. If that atmosphere is too thick, we're looking at crushing pressures and Venus-like temperatures. If it's thinner, perhaps enriched with water vapor or nitrogen rather than hydrogen and helium, it could be just right, or at least in the upper layers. Now, floating habitats in the atmosphere, similar to speculative designs for Venus, like NASA's HAVOC, could theoretically function in such an environment. Now, we're still talking hypotheticals, but this is a planet that invites that kind of thinking. Now, the planet's orbital period is about 290 days, 290 Earth days, which is intriguingly close to Earth's 265.24. Obviously, the 0.24 is how we end up with a leap year every 4 years, meaning its year is relatively familiar in length. It also receives about 90% of the sunlight Earth does, suggesting a potentially mild climate if the atmosphere traps enough heat. Now, that puts it right in the Goldilocks zone. Not too hot, not too cold, at least in terms of stellar flux. Now, we don't know yet if Kepler-22b has water. We don't know if it's breathable, landable, or survivable, but we do know this. It is a standout example of just how many Earth-ish planets might quietly be orbiting distant sun-like stars. Now, it's not the closest, it's not the most Earth-like in size, but in terms of conditions that might support some kind of life or human exploration with the right technology, it remains one of the most tantalizing early finds. Now, if future telescopes can pierce its atmosphere and tell us what's going on beneath those clouds, we might learn that Kepler-22b was never just a footnote in exoplanet discovery. It could actually be a stepping stone in our search for life, or even a template for the kinds of planets humans might be able to visit one day. Discovered in 2023, Wolf 1069b might not have the flashiest name, 69 dudes, but it's quickly become one of the most promising nearby candidates in the search for life beyond Earth. Now, orbiting a cool, dim red dwarf just 31 light years away, this rocky world checks nearly every box astronomers get excited about, particularly when it comes to potential habitability. Now, for starters, it's almost exactly the same size and mass as Earth, meaning its gravity would likely feel familiar to us. Now, that alone makes it very rare. Most known exoplanets tend to be much larger, falling into the either super Earth or mini Neptune categories. But Wolf 1069b, it's one of the few that feels like it could be a true Earth cousin. Now, even more encouraging is that it orbits right in the habitable zone, the region around a star where temperatures could allow liquid water to exist on the surface. Now, that is numero uno in the search for life. And perhaps most critically, its host star, Wolf 1069, is yet another unusually quiet red dwarf, giving its planet a fighting chance to hold onto an atmosphere. Now, this planet also orbits very close to its star, just 1/10 the distance Mercury orbits to the Sun. But because the star is so cool and faint, it receives just the right amount of warmth. It's also likely tidally locked, but the habitable terminator zone would likely apply here. Now, one of the most exciting things about Wolf 1069b is just how clean its solar system appears. There are no known gas giants or disruptive planetary neighbors that could throw its orbit into chaos or destabilize climate patterns. It's a relatively simple, stable system. And in the search for life, boring can be beautiful, but more importantly, safe. Now, we haven't yet confirmed whether the planet has an atmosphere, but it's high on the target list for upcoming telescopes like the JWST and the ESO's Extremely Large Telescope, easily the most originally named telescope in the history of telescoping. Now, these instruments could, in the coming years, sniff out signs of oxygen, methane, or other biosignatures, the kinds of chemicals that, at least on Earth, are closely tied to life. But for now, Wolf 1069b remains a mystery, a bit of a dark horse in the search for habitability. But it's close, relatively speaking, quiet, and could be just right. Another unicorn planet, just like ours. Now, the reality is that the search for exoplanets is really still in its infancy. Now, we've confirmed over 5,500 so far, but that's likely just a tiny sliver of what's really out there. Now, most stars have planets, some have entire systems, and somewhere out there, statistically, there has got to be at least one second Earth. Now, we might be a long way away from going there, but the fact we might eventually find one is really exciting. Now, if you liked or found this video interesting, go ahead and click on one of my other videos that should be popping up on the screen in a minute. And if you like those and want to see more, go ahead and hit the sub button. I'm trying to get these videos out every 2 weeks. I'm doing my best, I promise. I know I've been late a couple of times recently. I've been sick, and this mic picks up every little bit of gross, nasally sick sound that no one wants to hear. This is a fairly new channel, and the growth over the last month or so has absolutely blown me away. So I want to say a huge thank you to every single one of you who has watched, liked, and subbed. I genuinely really appreciate you being here, and I can guarantee you I'm working on some super exciting stuff in the background, which you'll have to wait for, but it's coming, I promise. Anyway, that's it for me. Thanks for watching. Have an awesome week, and I'll see you next time.